Welcome everybody to the first of our four-part series, Southern New England Vegetable Growers Meetings this winter, every other week this time, Thursdays 3:30 to 5. We had a lot of people register, 350 or so. Not everyone's here. We've got about 170 people on so far. So mostly from around New England, but some folks coming from farther afield. So because of that, we went with this webinar format where you guys can't see each other's video, which is kind of a bummer, but it just helps with the bandwidth issues. So if you have a question or comment at any time during today's workshop, just put it in the chat box and we'll get to it in time. You can also raise your hand if you have any issues or questions for us. And the pesticide credits, you should have been able to give us your registration, your pesticide license number information during the registration process. If for some reason you didn't, just feel free to get in touch with us. You can send an email to umassveg@umass.edu. If you want the credits, you've got to stay till the end. There's going to be a short quiz, and then we will get your form emailed to you within a few days after the meeting. So if after a few days you don't get your credit, then get in touch with us. But that's all the sort of housekeeping for today. We are recording this session and it will be posted online after today. So our first session here is Pests of the Year, and we're going to hear about tomatoes and potatoes and alliums, and we have crammed a lot into a short period of time, so I will not delay and we'll welcome Anne Hazelrigg to get us started talking about tomato diseases. So Anne is from the UVM Diagnostic Lab and is an expert on all vegetable diseases and flowers and many other crops. But
I'm a jack of all trades and master of absolutely nothing. So I should say, if I say this will stop other screen sharing, do I want to continue? And I say yes, right? Okay, so I'm going to share my screen and here we go. Okay, great. Thanks for attending, everybody. Hi, I'm the plant pathologist at UVM. I run the plant diagnostic clinic, so I see a little bit of everything every year. And I've been around forever and I keep staying around because you know what? It's still fun and interesting because I'm still learning new stuff every year. So I'm going to cover some of the tomato issues that I see, oops, to some extent every year. And I'm trying to forward and it's not moving forward.
The one thing we didn't test ahead.
Oh, there. Okay. All right. It's working now. Okay, great. So just remember, you know, starting at about a month or so or two, almost all the early season problems that you're going to see in tomatoes, they're almost all abiotic. And that means they're not caused by infectious agents. They're not caused by fungi, bacteria, or viruses. It's kind of abiotic. It's like cold damage, usually cold damage is the main thing. So these are pictures of what I usually get from tomato growers, you know, February, when they're freaking out all of a sudden. The picture on the left, you know, those the leaves are turning yellow and whitish actually, and they think they're losing their crop. And it's basically just cold damage. So the key thing to remember on some of these early season problems is always look at the age of tissue that's affected and look at the new growth. And if I look at the new growth and that looks green and healthy, that tells me there's a good root system there, you know, growing new leaves. But if the old growth looks yellow, something's happened while those leaves were small. And it's most likely, you know, putting plants in cold soils, maybe cold temps at night. but almost all these things, the plants will grow out of it. And tomatoes do really funky things with cold. This middle picture, all that tissue in between the veins is dead, and that's just cold injury. The other thing that cold does to tomato plants early season is it turns them purple because the anthocyanins build up. But the key is always look at the new growth. If the new growth looks good, you know, within a week, things usually warm up, the root systems warm up, and they start taking off and looking better. The other abiotic problem that I see early in the season with tomato growers is ethylene damage. And ethylene is a colorless, odorless gas that occurs when you have a cracked heater or incomplete combustion from a heater or improper venting. And tomatoes are like the canaries in the coal mine. They get this curled and twisted foliage, all from this ethylene gas, and it causes flower abortion, and just, it looks awful, and it looks like it just runs through the crop. It kind of happens overnight, basically, but it looks pretty bad. And people think there's something, you know, that's wiping out the whole crop. But again, the first thing to do is get your heaters checked, get them checked even before you put tomatoes in the high tunnel. Make sure everything is vented properly. But once you can correct that, if it does happen, if it's not too severe, the plants will grow out of it. That picture on the right, you know, that's pretty tough. That's pretty bad. They may have a hard time growing out of that ethylene damage. But curling, twisting, stunting, those are all symptoms of ethylene damage in tomatoes. Now, if you see that curling and twisting later in the season, we've been seeing, this isn't a plant disease, this is an arthropod problem, this is a broad mite, but that also causes curling and twisting of foliage. It almost looks like herbicide injury, but it's this teeny weeny little arthropod mite that doesn't overwinter in New England. It comes in oftentimes on bedding plants, but by the time you see it and it builds up enough to cause that curling and twisting, it also causes this bronzing on tomatoes, peppers, eggplant, peppers, and cukes. But that would be a late summer problem with curling and twisting leaves. So just be aware that that's a problem we're kind of seeing more and more, I think, later in the season. The other early season abiotic problem that you're likely to see late winter, early spring is edema. And edema is an abiotic problem that, you know, we're going along watering our plants. We're hoping that it's going to be sunny and 50 degrees outside, but it might be 10 degrees and cloudy, but you've already watered the plants take up all the water. It can't transpire it because it's cloudy out. So all this water builds up in those plant cells and then causes these sort of these little raised bumps, galls along the leaf veins on tomatoes. And basically the water builds up in the cells and then eventually it bursts and causes these corky lesions on the foliage. Again, look at the new healthy growth. Once you've slowed down on your watering or it's gotten warmer and sunnier, the plants will grow out of it just fine, but it looks pretty bad. And it looks like it happens all of a sudden, and tomatoes are very susceptible to it. So that's edema. Basically, the only real infectious disease problem that's going to happen early on in the season are root diseases and damping off. And that's a complex of 4 or 5 different soil-borne pathogens, soil-borne fungi that all like wet, cool conditions, and they cause either a root rot after the plants emerged, or they might even rot the seedling before it has even come out of the soil. But the way to avoid that is anything you can do to get that plant to germinate fast and outrun any of those pathogens will help. So like heat mats, make sure you always start with clean flats, use a soilless mix, keep temperatures on the warmer, the drier side. A lot of growers like to use root shield to compete with some of the bad guys for those sites on the roots. But that's really the most common infectious disease that you're going to see early on in growing tomatoes. And it can be a root rot. If you dig up a plant and take a look, you'll see these brown roots that you can just slough off. Also, sometimes if it's the plant's a little bit older, the picture on the right, that tissue just at the soil line has just been rotted away, and it almost looks like a mouse has fed on that tissue, but that's a root rot. So a little bit later in the season, we start seeing more foliage diseases, especially, you know, as the plants grow and the foliage starts closing in, humidity goes higher, and we'll see a whole lot more fungal and foliage diseases. Now, these are two diseases that you hopefully don't see in your high tunnel, because this is Alternaria early blight on the left and Septoria leaf spot on the right. And both of these leaf spot diseases, this is why everybody's moved into high tunnels, because both of these require leaf wetness to infect. So by moving into a high tunnel, you've eliminated that leaf wetness. So you really shouldn't see these two diseases in the high tunnel, unless sometimes I've seen it on the edges, on the outer rows of high tunnels where rain blows in. You might see some of these foliar fungal leaf spots, but typically you won't see this in a high tunnel because we keep things a lot drier and we're using drip irrigation. So those should be rare. The problem is with these other fungal diseases that don't require this leaf wetness, they just require high humidity. That's what we will have a problem with in high tunnels. And probably the most common that I see is leaf mold. And this is a fungus disease that really likes high humidity. It starts out lower in the plant because the humidity is higher down below, and it causes these bright yellow, almost like polka dots on the upper side of the foliage. But then if you turn the foliage upside down, you'll see these brown velvety spores on the leaf undersides. And this can be really common in high tunnels. And especially as the season progresses. Now, the way to manage that disease, it prefers humidity over 85%. So anything you can do to lower that humidity is going to help. So improve air circulation by using fans, rolling up the sides, opening up the ends, using top vents, use good spaces, don't crowd things, because the more crowded you have plants, the more fungal foliar diseases you're going to see. A lot of growers prune the lower leaves up to that first fruit cluster, and that can improve air circulation, and even putting fans down lower just to move the air around can lower humidity. There are also resistant cultivars. In New Hampshire trials, they found a list of cultivars that were much more resistant to the leaf mold fungus. So if that's been a real problem for you before, choose some of these resistant cultivars. You can use fungicides, but I guess I wouldn't recommend that until you've done everything else you can do to lower the humidity, because otherwise you're going to be wasting your money. If the humidity is still high, you're going to be spraying fungicides constantly and you're still going to be having the issue. Most growers live with the problem. You can spray Epsom, fungicides for the disease, and Champ, I guess, is the most effective. But really, if you can get that humidity lower, that's your best bet, and choose resistant cultivars. Gray mold is another one, botrytis blight. That's another one that likes cool, cloudy conditions, high humidity. And gray mold is a pathogen that will attack any dying tissue. So it can attack the fruit. That very first picture I had of the tomato, that was infected with botrytis. Any senescing tissues, flower parts, leaves. And what you'll see is that gray fluffy mold growing right on that tissue. So any senescing tissue with high humidity, it will attack. So if you do have a real botrytis outbreak, it can become pretty aggressive in a house. So clean it up, open up the house, lower that humidity, pick off and destroy, clean up anything that's senescing tissues. Don't just drop them on the greenhouse floor, get them out of there so you're not providing inoculum. So Gray mold also likes cool, cloudy conditions, so watch for that. Powdery mildew is another one that likes high humidity, but probably warmer conditions. And powdery mildew is easy to diagnose. It's that white powdery coating on the foliage. And we've had more and more problems with this over the past few years. And a few years ago, a lot of growers bought in transplants that were already infected with powdery mildew and really could never get a handle on the disease, even by spraying. So a lot of people just gave up because they just couldn't keep up with the disease. So it causes dieback on the foliage. So I went into some greenhouses the year that it all came in on the transplants, and basically the top foot of the plant was still alive, and that was about it. So it can really wipe out foliage. The important thing to remember about powdery mildew is that it only lives on live tissue. So even if you had it last year and you didn't keep any tomato plants alive over the winter, you won't have it this year because it has to have live tissue to live. It doesn't overwinter. So you're starting from scratch every year on these. But the thing is if you purchase in seedlings or transplants, you want to really carefully inspect whatever comes into the high tunnel. And don't let anything in that you suspect is infected with powdery mildew, because it's just going to be you're fighting a losing proposition if it starts early on. Scouting for that disease is really important, because the earlier you catch it, the easier it is to control. It likes cool, low light conditions. And another important thing to remember about powdery mildew is that powdery mildew, you see it on lilacs and cucurbits, you see it on lots of different plants, but powdery mildew is very host specific. So the tomato powdery mildew is not the same one that's attacking your cucumbers. So they may like the same kind of environmental conditions, and that's why you see it at the same time, but it's not the same pathogen. So I talked with Meg McGrath a little bit about what her recommendations were for powdery mildew. And her recommendations were, if powdery mildew was present early, like during the vegetative phase of the plant, start with using sulfur as a control, because it's the most effective fungicide to use, and it's a good organic fungicide. But once fruit is present, that sulfur can leave a residue. So you want to switch to mineral oil or JMS styloid oil that's just below sulfur in efficacy, but you don't want that residue to remain on the fruit. Also, remember that you can't apply sulfur and oil within 14 days of each other, because the oil will enable the sulfur to move into the leaves and can cause phytotoxicity. Millstop and Armacarb is another effective non-sulfur based fungicide you can use for powdery mildew. Late blight, that's another foliar fungus disease, fungus-like organism, and luckily the past 2 years we have not had it in New England as far as I know. We definitely haven't had it in Vermont, and last year was no exception. It was in Western New York and down in the Philadelphia area, but Meg had felt like these were probably from coming in on potatoes that had overwintered in the field, and people had missed those. So we really didn't have the storm fronts. Typically this disease doesn't overwinter in New England. It leaps up on storm fronts coming up from Florida, and we just didn't have the weather patterns that brought it up to New England last year. So that's awesome, because even though you're in a high tunnel, you're not, if there's a lot of inoculum around, you're not immune. Your tomatoes are not immune from late blight. You've got to get in there and spray with a fungicide if you want to protect them. Okay, as far as mid-season, later season foliar issues, and an abiotic problem we see to some extent every year is magnesium deficiency. It could look like it causes that interveinal necrosis and yellowing between the veins. Starts lower in the plant, can work its way up. It looks worse than it is. Most growers just live with it. Doesn't really affect yield much. And if you've pruned off those lower leaves up to that first flower cluster, you're sort of, you don't have to look at it as much. But that's magnesium deficiency. It can usually shows up when there's a heavy fruit load, if you've got high potassium or high ammonium nitrogen fertigation. Vern has a really good fact sheet on using Epsom salts if you want to use that to minimize magnesium deficiency, but for the most cases, it's not necessary. Okay, how about fruit problems later on in the season? Fruit problems that are abiotic or non-infectious. One thing we saw a lot of last year, or at least I heard of from growers, is a lot of flower drop in high tunnels. And that can occur anytime we have over 85-degree daytime temperatures, or if we have over 70 degrees at night. And we've had some hot, dry summers the last few years. And so don't be surprised if your plants drop flowers all of a sudden if you've got these high temperatures. Also, we tend to see poor pollination if we have low humidity or really high humidity. So just be aware, if you see a skip in production, it might be caused by something that's not an infectious organism. It's just the environmental conditions. So anything you can do to lower temperatures, I don't know if people use shade cloth, things like that, that may help. Blossom end rot, the middle picture, that's another common issue caused by calcium uptake and moisture fluctuation in the plant. Typically, the first fruits produced have more of a problem with this, and then the plant kind of figures things out, or else the grower figures out irrigation. I've noticed that some cultivars are more susceptible to this than others. And then the other, this third picture on the right is called gold flecking. And everybody's heads are covering up my notes, but it's with when daytime temperatures are over whatever it says there, I can't see it, 85 degrees, I think, but with high humidity. And again, some cultivars may be prone, but that's another abiotic fruit issue that we've been seeing in these hotter summers. This is a problem we saw also last year. This is an infectious disease. It's an anthracnose, a fungus disease, but it was occurring on overripe fruit or ripe fruit over 80 degrees Fahrenheit. So I think things had just been picked too late, and the fungus would really take off on some of this fruit. So I know a few of our growers were seeing that issue. A new fruit issue that we're seeing, I haven't seen it in New England yet, but we're on the lookout for it. And if anybody sees this, we'd really like to know about it. You want to talk to your agency of agriculture or the plant diagnostic clinic. It's a new virus disease called tomato brown rugose virus. And it was first reported in tomatoes in 2014 in Israel. Causes fruit loss in tomatoes and peppers. You get wrinkling and stunting. It's in the same family as, I think, tobacco and tomato mosaic virus. And so you see that mottling and roughened fruit. It was found in California and Arizona, but eradicated, and it can be spread really easily through contaminated tools, hands, and through seed and plant-to-plant contact. So when I was talking to Meg about it from Cornell, she was saying she thinks it's probably pretty widespread, but growers are not reporting it. So USDA is doing a lot of seed testing and transplant testing to hopefully catch this before it really becomes a problem in the country. But we would appreciate if you see anything like this, please let us know, and we can get samples to the USDA and figure out if we do have it. Okay, what if you walk in your high tunnel late season or early season, it doesn't matter. What if your plants are wilted? Well, the very first thing, if all the plants are wilted, first thing you want to think about is watering. You know, is it too dry? Or are you not watering enough? Is it too wet? But you always want to look lower in the plant. Anytime you see a wilted plant, look lower in the plant. It could be a root rot or a crown rot. It could be a canker disease like white mold, or it could be a vascular disease like bacterial canker or pith necrosis, something that's interrupting the flow of water and nutrients upwards. So you always need to look closer. This was a picture from a grower earlier in the season that seeing a lot of wilting in plants, and actually things were too wet. And once they dug up the roots, that's always really helpful. Just taking a look at what a root system looks like, and they could just strip off all those brown roots, and that's pretty common for one of those root rotting pathogens. So they were just watering too much early on in the season when it was cool and wet. This was another issue that we saw in Vermont and maybe other places in New England. One of our growers used a new root stock called, and I can't read that either because I can't see it, Xinjiang something, I can't read it, Chinese root stock. But the plants on the right were planted on that root stock. The plants on the left were on, I don't know if it was Maxifort or it's a root stock that she normally would use. And there was a lot of stunting. It didn't kill the plants, but a lot of stunting in the house. And she was really afraid she was going to lose the crop. And luckily, as the season went on, the plants recovered. And there may have been a nutritional issue there too on that, in that one row. But basically, when we looked at the root system, we saw a lot of evidence of this root disease called corky root rot. And it's a fungus disease that can be common in high tunnels when you're not using a resistant rootstock. And I think Maxifort is considered pretty resistant to this disease. But, you know, in tomato houses, we plant tomato after tomato year after year. And if you're not using a grafted rootstock, you're going to really be prone to a lot of these root diseases. So I think that's what was going on with this sample. Excuse me. Usually doesn't kill plants, but it will reduce yield. So something to be concerned about. And there was just a discussion on our Vermont Veg and Berry listserv about, okay, do you have to start right out with grafted rootstocks? And I think the general consensus is you probably have 4 or 5 years grace period before you need to have a grafted rootstock. But over time, these soil-borne diseases will build up, and you're going to need to use grafted rootstocks to avoid some of these root problems. So if you see wilting, leaf edge dieback, always look lower. You might see a canker at the base of the plant. One of the most common ones is white mold. It's easy to diagnose. It causes a fluffy white rot at the base of the plant where air circulation is porous. It's a hit or miss problem. You usually see it in wet parts of the greenhouse. And the important thing with this disease is it produces a long-term overwintering structure called a sclerotia. And it looks like a black mouse dropping. And basically, if you see that disease in your house, you want to cut it off at the base, get it right out of there, because you don't want these sclerotia to drop into the soils, because they can kind of hang out there for 7 to 10 years and infect when they get just the right conditions again. So that's white mold. That's a canker disease that you should look for if you see wilting in the top. The other thing to look for if you see wilting are these vascular diseases. And there are 2 of them that we see. One is tomato pith necrosis that we've been seeing more of. And this is a disease earlier on in the season when it's cool, cool nights, high humidity, cloudy, and plants are vigorous because of high nitrogen fertilization. And one of the symptoms are lots of adventitious roots on the stem. And if you cut open that stem, you'll see that blackening in the pith. Luckily, this disease, you know, once the weather becomes sunnier, warmer, a lot of times plants can grow out of this. And so it's not a death sentence for the plant. But there's another vascular wilt disease called bacterial canker that would occur later in the season. And you'll see this leaf edge dieback. Usually occurs when there's a heavy fruit load. And if you cut open, you see that blackening in the vascular system, that could be this bacterial canker. And this is a really bad one. This is one that you want to, anytime you see blackening or darkening in the vascular system, I would send it to one of the clinics, the plant diagnostic clinics, there's a rapid assay that we can do to test for this bacterial canker, because if it is that, that can really run throughout a whole house and wipe out the whole house pretty fast. So that's one that we don't want to see in greenhouses. It's really destructive. It's easily moved by pruning and suckering. So you want to, if you've got that disease, you want to destroy the plants. Don't work in that greenhouse and then go out to your field tomatoes, but get that tested, and then you know, just be aware if that's in your greenhouse, and we're happy to test that for you. So basically,
Great. I was about to say we were getting a little bit over time, but
yeah, so that's, yeah, I'm done. I'm just going to say, you know, use your plant diagnostic clinics. We're happy to look at pictures. If you see a problem, maybe we can figure it out just through pictures, but we're happy to look at samples too. You've got a great clinic. Every state has a clinic associated with their land grant university. So thank you very much.
Yeah, thank you so much, Anne. That was great. There's so much going on tomatoes every year. So
I know.
Appreciate you trying to fit so much in there. If you want to stop sharing, we'll pull Tom up here quickly. And he's going to talk a little bit, just a few short minutes about some crop insurance programs, coronavirus relief, and I'll let him take it away. Thanks.
Hey, thank you, Sue. Again, thanks. I'd like to thank, you know, Connecticut, Rhode Island, and the Mass Vegetable programs for allowing me a little bit of time. Just briefly, want to talk about some upcoming deadlines on March 15th for federal crop insurance. Again, very few vegetable crops are covered by federal crop insurance. In New England, sweet corn is available in all counties, potatoes in select counties, for instance, and I focus my notes to the 3 southern New England states, but if you're outside of Mass, Connecticut, Rhode Island, you can check with me or check with the extension in your state to find out if you're covered. For instance, Massachusetts, only Franklin and Hampshire are covered for potatoes. Connecticut is Hartford County, Rhode Island's Newport and Washington County. And the other policy that is available is the whole farm revenue policy, which is a revenue-based policy. This deadline of March 15th applies to new policies or a revision to or canceling an existing crop policy. And federal crop insurance is available from private crop insurance agents. The other program I wanted to mention along these lines is the Non-Insured Crop Disaster Assistance Program, or NAP, which is available through the USDA Farm Service Agency. Both these programs cover crop losses from weather-related causes. I'm just going to talk a little bit more about NAP because there's going to be a lot more applicability to vegetable producers. So under CAT, there's 2 different coverage levels. There's catastrophic coverage level, or CAT, or buy-up coverage. And the producer chooses which crops to obtain NAP coverage on. So if you happen to be growing 10 different crops, you can get coverage on all 10, or you can get coverage on anywhere between 1 and 10. The CAT coverage covers losses that exceed 50% of the producer's historical yield, and any payments are based on 55% of the established price for the crop. Buy-up allows coverage for losses that exceed 50 to 65% of the historic yield, and then the payments are based on 100% of the market price. Now, under CAT, producers pay a service fee of $325 per crop for up to 3 crops in a county. Above 3 crops in a county, there's no additional charge. So if you're growing 10 crops, you're only going to be paying for the first 3. On buy-up, because your coverage is you can get a higher percentage of coverage, and the payments are based out at a higher rate. The buy-up cost is the NAP service fee plus 5.25% of the guarantee, which is the yield times the price times the percent covered, and then times the acres. Now, an important point to make under NAP is the fact that FSA waives the service fees and reduces buy-up premium by 50% for beginning, historically underserved, which also includes female operators and limited resource producers. So really, if you fall into one of those categories, the CAT coverage, there's no cost for you. And if you elect to go buy up, then you can get a 50% reduction on that. So again, we'd really encourage you to talk to your FSA people. You still have roughly 2 months to sign up, but it's a good time to look into this. And as we know, weather is really up and down lately, and something again to consider. The other thing I want to spend a little bit of time on is the coronavirus relief bill that was signed by the president on December 27th, and applicable, really what's applicable to vegetable producers. At the current time, USDA FSA is writing the regulations, and we would expect that sign up would probably begin sometime in February at the earliest. A couple of changes for those of you who are familiar with the CFAP2 program. A couple of significant changes is that under this relief bill, if you received federal crop insurance indemnity payment or a NAP payment, you're going to be allowed to allow those two payments to be added to your CFAP2 eligible sales to determine payment. So that's something to consider. The other significant part of the bill in this regard is that you will have the option of using 2018 sales instead of 2019 sales. So, is that those who participated, remember you use your 2019 sales under the provisions of the relief bill. If 2018 is greater, you'll be able to go back, I believe, and revise your application. What's unknown at this time is if producers who did not sign up for CFAP2 initially, I think the program ended December 11th, whether or not they'll be allowed to sign up under the new provisions. And just to show an impact of the CFAP2 program, in all of New England, there were almost 5,000 applicants who received over $120 million under this program. That's total. That includes dairy, corn, grain, everything. The group that covers vegetables, there were over 3,200 applicants and over $75 million was paid out to those producers. So very significant payments. I worked for FSA for over 35 years. There was never a program that even came close to the amount of assistance that was paid out, and especially the vegetable producers who, as so many know, a lot of the federal farm programs historically have not done a lot for vegetable growers. So something to keep in mind going forward as they announce these provisions. The last program I wanted to mention under the coronavirus relief bill was the Paycheck Protection Program. And this is a program that's administered through the local lending institutions that are following guidelines from the Small Business Administration. Paycheck Protection Program came out last summer. The intent was basically to keep your employees on board, during the period that was eligible. And there were a number of farms that did participate in the Paycheck Protection Program. And while the Paycheck Protection Program, the premise is a loan, SBA will forgive those loans if all employee retention criteria are met, and also 60% of the loan proceeds are used for payroll. So again, something to look at. It can be a little bit complicated as far as what's eligible and what's ineligible, but my advice would be is to talk to your agricultural lender or a local bank and see if Paycheck Protection Program can fit in for you. Deadline for Paycheck Protection Program is March 31st. And then additional information for the coronavirus food programs. go to farmers.gov. Farmers.gov will have the information as soon as it's available in terms of sign-up days and different criteria. Our program will also be pushing this out through Mass Veg Notes, New England Vegetable Berry Growers Association, Mass Farm Bureau, and also Mass Fruit Growers. So we're going to try to help spread the word out on this. And for Payment Protection Program, you can go to sba.gov for more information there. Again, talking with your local lenders. With that, that's a really brief, quick summary. And again, thank you for the time.
Sure, thanks a lot, Tom. It's always good to hear a little from the crop insurance team. Appreciate that. And yeah, definitely a lot of growers have gotten a good amount of support this year. So keep that going. Andre, you are up next if you want to share your slides. And for those of you, listening, it's quite a whirlwind afternoon here. Fitting a lot into a short period of time so that we're not sitting at the computer too long, hopefully. But we're going to hear next about Colorado potato beetle, which I'm sure many of you saw a lot more of than you were hoping to this year. So Andre is from UMaine and he's expert on this pest. So take it away. Thanks.
Okay, good afternoon. And I'm going to talk about Colorado potato beetle. It is pest of the year. A big question is pest of which year? I've been working on this for a while, since I was in graduate school. So this is a picture of me back 25 years ago. If somebody starts gasping and saying, I can't believe that's you, that person is not going to get pesticide credit, so don't do that. Use your chat function for better purposes. But you can probably tell that things have changed since then. But one thing that pretty much stayed constant is that Colorado potato beetle still remains a background problem. Sometimes it gets better, sometimes it gets worse, but it's usually there. I even wrote an article about that 3 things that are constant in life of a potato grower are death, taxes, and Colorado potato beetles. So as I said, I've been working for that for 25 years or so. Does it make me an incompetent loser? It's kind of a philosophical question, but I don't think so. Although you may disagree. It is a very difficult pest to control. It's rather voracious, and both adults and larvae feed on potatoes. It's prolific. Females lay on average probably around 600 eggs, can vary up to 1,000, 1,200. It's highly mobile when it wants to move, although it doesn't always want to move. It has no effective natural enemies. There are natural enemies that contribute to its control. Sometimes they can keep it more or less in check, but you cannot really rely on them, unfortunately. So it is a problem. So this is how uncontrolled plots can look like. I don't know if you experienced anything like that. We see it on our control plots all the time compared to protected plots. And here is the damage. One thing that's quite typical of this pest is its ability to develop insecticide resistance. And this is what probably makes it, it's one of the main factors why it's so difficult to deal with. This is a summary. I haven't updated it. It's like maybe 6 years old, 7 years old, something like that. But, this line continues sort of into here. You can see cumulative number of chemicals that failed, and you can see that consistently cases pop up that are entered into a pesticide resistance database. So there is constantly pressure from Beetle towards, or I guess there is a pressure from insecticides for the beetle to develop insecticide resistance. Doesn't mean that every population is resistant to every chemical, but there are certainly populations that are resistant to multiple chemicals. So there are probably some organic growers in the audience. Sometimes there is kind of a mindset that or I should say maybe there was a mindset, I'm organic, insecticide resistance is not my problem. I am doing all kinds of different things. And this is a large monoculture kind of growers who experience that. There is some rationale in it because indeed, if it's a smaller diversified production with crop rotation, with other cultural methods, there is, with extended crop rotation especially, there is less of a chance to develop insecticide resistance, but there is one thing that works to a grower disadvantage, and that's a very limited number of chemicals available to organic growers. So people are forced to put all eggs in one basket, and this basket for a while was basically spinosad, and trust natural light. And we do see resistance to spinosad everywhere. This is some work we did several years ago on an organic farm. It's about as organic as it gets, mixed vegetable production, very intelligent, very knowledgeable growers. And you can see that concentration that's required to kill 90% of population for susceptible beetles from research farm is about 220 mils times 10⁻⁷. But for this farm, it's 2000, almost 2200. So 10-fold difference. Start seeing some performance problem. This is our recent paper also looking at spinosad resistance. And if you look at air column, which is a resistant ratio, how much more of a chemical it will take to kill beetles from a certain population, you can see that it can be any time from 4 or 5 times to about 60 times more. So there is a considerable resistance compared to this susceptible population. Again, anecdotally, some of the organic growers complain that they do not use spinosad anymore because it's useless. Okay, so why is it such a problem? So there are basically 3 major components to it. One is coevolution with solanaceous plants. Potato vines are fairly toxic to begin with. It's a nightshade, essentially, a grassy kind of nightshade. And beetles already have physiological adaptations to overcome that. They have high fecundity, so there are lots of them, and chances of some of them, say, develop mutation and become resistant, or some of them escaping an insecticide application somewhere are high. It also doesn't take much to build back up once, say, resistance developed, or once people became complacent and stopped controlling. And there is a diverse and flexible life history. Beetles, they're like everywhere. They are within the crop, they're outside the crop, they walk, they fly, they burrow into the soil, both for pupation and for overwintering. They have high genetic diversity. They mate multiple times with multiple partners, so all the progeny is mixed up and have hybrid vigor. Basically difficult to deal with. Okay, so does difficult mean impossible? No, it does not. Anybody can tell me who this is? you can send me a text. Any text? Actually, how do I look at the text?
Someone said Confucius,
No,
Genghis Khan,
no,
Lao Tzu.
no.
Okay, who is it?
This is Sun Tzu, the author of The Art of War.
Ian did
And
get
he
it.
said, for to win 100 victories in 100 battles is not the acme of skill. To subdue the enemy without fighting is the acme of skill. So if you can get the problem from getting out of hand, then you will end up on top. If you're constantly one step behind the beetle and just react to things happening, then you're not going most likely to win this battle, or if you win it, it will come at a high price for your wallet, for your emotional well-being, and possibly for your physical health, because you have all those residues around. So, I don't want to beat dead horse, but practicing integrated pest management is especially important when you are dealing with something that Colorado potato beetle, which it uses, I guess, integrated pest, whatever, integrated pestiferous. As I said, it's here and there, and you can hardly get it. So what does it mean? First of all, IPM begins with educated use of pesticide. The golden rule of pesticide use is, as you hopefully know, do not use it unless you absolutely must use it. And here is a figure from a published paper that summarized published literature. And what it shows is how much, what's the maximum amount of defoliation that potatoes can tolerate at different stages without yield penalty. And you can see that, real small potatoes and real large potatoes can tolerate like 3/4 of leaves gone without yield penalty, believe it or not. I'm not saying that you should get to that point. It's too risky, but it shows that potato is quite tolerant. Small ones can grow out of it. Big ones, you're at the point when you need to kill vines anyway, assuming you kill them. So why bother? They already are done accumulating nutrients. And, during the year, it's less than that, but still like up to 40%. So basically, you don't have to freak out each time you see a beetle. You have to freak out once you start seeing too many beetles. Do not use insecticides that belong to the same chemical groups. There is a considerable cross resistance. So this is resistance to two neonicotinoids, imidacloprid, thiamethoxam. You can see this relationship. And the relationship holds even for beetle populations that were never exposed to imidacloprid, because those are similar chemicals, so they work similarly. So this is how it looked at our experimental plots with resistant beetles. Somewhat better than control, but not much, and not much difference between different insecticides. And this is how it all looked towards the end of the season. So do not follow insecticide by the same insecticide. Look which group this insecticide belongs to. And if it's the same group for mode of action, do not use them together. So you alternate, and you make sure that you do not use the same chemical to attack the same life stage. If you target larvae, use different chemicals. This is, it's kind of a complicated graph without reading it, but the bottom line is that try alternating chemicals, not just within the season, but between the seasons. So this paper, which I think is actually available for free, is listing this diagram. So if you're curious, have a look. Okay, if you do need to use something more than once, use one after another, again, targeting the same life stage. This way, functionally, it's like one extended application. Do not apply on subsequent life stages, because this way you select more. So you have the ones which are resistant because they survived the first application, you hit them by the second application, then you eliminate everything that's not completely resistant. So you end up with highly resistant population in the end. Do not rely just on insecticides, use multiple attack strategy. Crop rotation, some of our work. You can see beetle density on rotated fields, not non-rotated fields. Slightly lower on rotated fields than non-rotated fields. And this is even though about twice as many insecticide applications went on non-rotated fields than on rotated fields. Data from commercial farms. Okay, sometimes you may get a little help from places where you didn't expect. For example, oil, which is applied usually to prevent PVY transmission, actually has some negative effect on Colorado potato beetle, and it also synergizes with Beveria bassiana, a fungus that's usually more or less present in the environment. It can also be purchased and sprayed. And if you mix oil with Beveria bassiana, beetles die quicker than then if you use just Beveria bassiana here. You can see mortality beginning like right ahead on the first day since treatment, because probably it helps to get inside. Also, soil management, I mean, it's important obviously for many different reasons, but it also helps against insect herbivores, including Colorado potato beetle. If you have healthy plants, they are better able to withstand beetle damage, they are better able to produce defensive compounds, and possibly your soil will also produce support more natural enemies. So again, here is our data. Whenever you see an asterisk, this is when beetle populations of different life stages were smaller on plants grown in soils amended with manure than on synthetically fertilized soils. Okay, and this continued like year after year after year. It was a long-term project, and that's despite the fact that canopy cover and potato height were pretty much identical between amended and non-amended plots, and the yields were actually higher on manure amended plots. So it's not like we had bad plants that didn't support beetles. And some more detailed studies showed that actually beetles would consume New Brunswick, and you can see the differential was bigger when it came from organically managed soils than from regular soils, but or I guess not non-organically managed soils, but soils that received manure. Okay, so the bottom line is that if you don't want to have beetle populations getting out of hand either this year or next year or a few years down the road, do not just try chasing them around with insecticides. You have to use insecticides intelligently. You have to rotate different modes of action as much as you can. You do not rely on insecticides alone. you have to have a good ecosystem going on there. You know, you rotate. The longer you can have, the more extended rotations you can have, the better. The further you can rotate between the fields, the better. You know, it's easier said than done, obviously, because land is somewhat limited in this neck of the woods. But still, you know, whatever you can do it. Make sure that your soil is, you know, amended, that, you know, you have high organic matter contents. So all that would contribute to less of a beetle problem. So a couple plugins. This is a book that's available, and I'm one of the editors, so it's a must read for everybody interested in insect pest of potatoes. And also a shameless plugin for the UMaine IPM Council, of which I am a member, and we will have a display booth on our virtual display booth on our virtual UMaine Egg Trade Show. So if anybody is checking it out, please stop by our booth. There is some good information on the website. So I think this is pretty much everything that I wanted to say, but I will be happy to answer questions. So I guess I will stop sharing the screen, and then I don't know how we're on time. I think
Yeah, our
more or less.
time is super tight, and it's just a packed program. So I wonder if you could answer one question while Ethan's getting set up, and then we'll do questions at the end if you're able to stay a little bit after 5. So the one question that I thought maybe you could talk through just a little bit is if there are any physical methods that you know that growers have used successfully to exclude
Physical control methods depends on your size. You know, the best method is just to go there and pick up egg masses and colonizing adults if you can. Some people use propane flamers. You need to check your regulations whether it's considered to be like an open fire or not. It does damage plants, but plants grow back. Beetles not so much. I worked with trenches some. They help, but whether they are worth messing with or not, I don't know. There was a number of vacuums. There is still a group in Canada working on improving those vacuums. I guess they work to some degree, but people, that was kind of an act of desperation in mid-90s when nothing worked. And after imidacloprid came on board, it's discontinued. The problem with vacuums, lots of dust, which is not good to breathe in. And it also can cause some issues once it's settled on foliage. So, you know, this, I guess, I don't know how much this answers your
that's
question.
helpful. Yeah, just to get ideas. And if anyone has successfully tried any of those things and you want to share your experiences in the chat, you should be able to send messages to all panelists and attendees. So if you want to give that a whirl. And thanks, Andre. We'll turn it over to Ethan Grundberg from Cornell Cooperative Extension to talk about a new pest in town. Thank you so much.
Yeah, thanks, Sue, for the invitation, especially since I used to farm in Eastern Massachusetts and recognize some of the names on the list here. So hi to everyone I haven't talked to for the last 5 years. I'm still alive. I am going to be talking about Allium Leafminer, a relatively new pest in the region, and some of the research we've done on management strategies for the pest. If I can get the slide to advance, a real quick explanation of who we are. I work for the Eastern New York Commercial Horticulture Program, which is a regional team of Cornell Cooperative Extension. There are 5 vegetable specialists that cover that whole 17-county area highlighted in red here. I am based way down here in Orange County, where there is a 12,000-acre deposit of very highly fertile muck soil, where there are still about 4,000 acres of conventionally grown bulb onions every year. Real exciting place to be. So we're going to talk about Allium leafminer, and it is a pest originally from Poland. It is believed, and over about the last 30 years, has kind of been spreading throughout Europe, made its way to the UK in the early 2000s, and then we had the first North American confirmation in Lancaster County, Pennsylvania in 2015. And you can see since then it has spread. Katie Campbell Nelson found it in Berkshire County in Massachusetts in 2018, and it was found for the first time in Connecticut in 2020. Now you can see these big gray areas in between where we have confirmations. It is entirely probable that the pest is already present in those spaces as well. So I don't think that if you're not on the map, you're off the hook. You may be dealing with it anyway. It's a pretty poor flyer, but nevertheless, it has spread rather quickly. So we don't have a great explanation for that, but I'd be happy to make something up if someone really wants me to. There are 2 flights of Allium leafminer per year. Like all leaf miners, essentially it is a fly. The adult is a fly. So these kind of nondescript small flies emerge from the overwintered pupae in early to mid-April, and then they do their thing for about 5 to 6 weeks through the month of May. You might be able to see in their better pictures later in the presentation, those little regular circular marks under that fly. Those are what are called oviposition scars. So the adult females have basically a syringe coming out their abdomen that they use to lay eggs. And in this case, the adults both lay eggs in those oviposition scars, but also actually slurp up some of the plant juices that are excreted from those oviposition scar sites as well. So not all of those oviposition scars are active egg laying sites, but there are some eggs that are laid, and these fun little maggots hatch out from the eggs after a few days, depending upon temperature, mine their way down the plant towards the soil, and then pupate again, either in the plant itself or in the surrounding soil for most of the summer. And then we get the fall generation, which is the one that we're really concerned about, where we see the most economic losses to cultivated alliums. Same cycle, but the flight is a little bit longer, we've observed in the fall. So we typically get emergence of the adults in early to mid-September, and we've still found adults hanging out in trial fields in early November. So more like an 8-week flight in the fall. And then those pupa overwinter and become the next year's spring population. Just to give you a quick visual overview of what that looks like. Again, this is what the fly is. The fly looks like a fly. I mean, don't go out looking for flies. The flies are almost never in the field. You won't find them. What you will find, what's very easy to spy, are these diagnostic oviposition scars. And so typically what we do is we recommend scouting around when you expect emergence, 20 plants or so on field edges, which is where we often usually see the first activity, and just look up near the tips of those alliums for those oviposition scars. That will be your best clue that you have the pest in the area. This little boogery thing next to it is an egg. You won't see those either. That's under a dissecting scope. When the maggots hatch out, the larvae, they're really tiny. They go through several different instars in development. And as they mine their way down the leaf and leave these nice mining scars that you can see in the next set of pictures, they get bigger until they're that big down there in that leak shaft. We do sometimes see some foliar distortion, especially in bulb onions, where that physical damage in the plant has forced the plant to kind of try to grow up around that obstruction. We don't see that in other allium species necessarily, but if you see that in your dry bulb onions and you aren't using absurd amounts of herbicide, that might be what's going on. And then finally, here you go. Those are those pupa that were promised embedded in the plant tissue. I do really quickly want to point out the browning in that leak shaft. That is bacterial soft rot. And that's one of the biggest issues that we see, is that the physical damage, again, caused by the maggots serves as an entry point for those bacterial soft rot pathogens. And then you get a really disgusting mess on your hands. So here again is that same kind of explanation of when those generations happen, but transposed over when we typically see cultivated alliums out in the field. So I already mentioned the spring generation doesn't seem to be as much of an issue. There are a couple theories on why. It does seem like the adult population is lower in the spring, But you can see we just have a ton of alliums, including a bunch of wild alliums in the environment. And the theory is that perhaps between the lower population and all the different potential hosts, we're just kind of diluting out the population in the spring. And we'll see some research results that have kind of backed that up as we go on. Where we really see a problem is in the fall, especially in leeks. We'll see some disgusting leaks right now. There you go, boom. So what do we see when we see damaged crops? Well, we already saw, I think it's the exact same picture of the soft rot there, but even just having, you know, some of the physical mining scars and the pupa present in the leek after you peel back those outer couple layers, no one wants to buy that leek. Maybe a CSA member will take it reluctantly. And then here on the right, I do want to point out, as I've said several times now, the spring flight's not really the concern, but when we did this trial with Spanish Roja garlic a couple years ago, we did find that even though we had low levels of infestation, we did have some pupae that were embedded in those wrapper leaves around the bulb of garlic. And so I share this not so much to say like your garlic is at risk, because it's not really. But if you're buying in seed garlic from a region where there is Allium Leafminer pressure and you don't have Allium Leafminer, just to go back to this kind of timeline really quickly, if you are on top of things, which I never was as a farmer, and you put your seed order in August and you want it shipped immediately and it gets there the 1st of September, you might be bringing pupa to your farm. So maybe just pump the brakes and ask them to ship it late September and have those pupa hatch out into adults on their farm, not on yours. All right, so we've been doing a bunch of research and we'll start going through it. We're going to start with insecticides. So when we deal with a new pest that we don't have a lot of research data on, the first thing we do is illegal. So I don't want anyone to think that these are recommendations. This is simply data that we're sharing to show you some of the products that we've screened that show some promise to use in an insecticide program. I think Andre will never agree to present on a panel with me again if I give anyone the illusion that you should spray the same mode of action 6 times in a row on the same pest. Don't do that. All right. That said, we have done these insecticide screenings both in the spring and the fall, I think 4 or 5 times now. I'm not going to show you all the data because I already am going to overwhelm you with bar graphs. But here is one bar graph that pretty well summarizes what we've seen in most of the screening trials that we've done. So the bigger bar graphs are the ones where we saw more damage from Allium Leafminer. The ones with the smaller bars are where we saw less damage. So for the conventional growers, as is almost always the case, you have a lot more options available to you. Warrior, which is a synthetic pyrethroid, did really well in this trial. It slipped a little bit in other trials, so that's the only kind of anomaly from this data set. Radiant, which for the organic growers is kind of like the conventional synthetic version of the same active ingredient, and then Trust has worked consistently really well. Scorpion, which is not labeled for use in New York, I believe it is in Massachusetts. It's a class 4D neonicotinoid. That has consistently been one of the top performers, both in New York as well as in the trials that have been conducted in Pennsylvania by some of our colleagues doing similar work. And Exerol, which is a diamide, group 28 newer chemistry, which growers always hate when I recommend it because it's really expensive. So even though we have not trialed it, I do want to point out that some growers, and observationally it's been successful, have used Minecto Pro instead, which is a premixed product that has the same active ingredients that are found in Exerol as well as Agramec, abamectin. One caveat, it is not labeled for use on dipteran leaf miners, and Allium Leafminer is a dipteran leaf miner. Some labels, for some reason, feel the need to specify Liromyza leaf miners. So I cannot officially recommend its use, but there you go. Now, for OMRI listed products, you'll see pretty much everything does really poorly, which is disappointing. We have also screened Surround and a couple others that aren't in this trial. Nothing really has worked except, of course, Entrust. One quick thing to point out, Entrust plus Impede. Impede is an insecticidal soap. It has consistently performed slightly better than Entrust by itself or Entrust with new film P. The thought is that Impede is acting basically as an adjuvant, a penetrating adjuvant, helping to get through that really thick waxy cuticle on the allium leaf, and helping Entrust kind of exercise its translaminar activity, which is getting through the leaf tissue and hitting those lovely little maggots that are inside the plant tissue. So you'll see as we continue on, that our recommendations for Entrust always include a co-application with MPED, basically as an adjuvant. So since I already told you it's illegal to do what we did to get that data, don't do it. The next question obviously was, well, now that we know some potential chemistries that might work, can we get away with making 2 applications in that kind of long flight period and get similar results in terms of suppressing the pest? So we decided to kind of hone in on Entrust and MPED, Entrust at the 6 fluid ounce per acre rate and MPED at that 1.5% concentration. And we designed a trial where we looked at all of these fun treatments. So just real quick, treatment A is where we did the illegal thing that you should not do and sprayed every single week. We had some plots where we did nothing, sprayed nothing, let them have a feast. And then we did all these different sort of combinations of 2 applications. Once we observed overposition scars in the trial plot, spraying in week 1 and 2, 2, 3, 3, 4, 4, 5, and then skipping a week in between. So applications in weeks 1 and 3, 2 and 4, and 3 and 5. And here's what we found. In 2 years of doing these trials on fall-grown leeks in Hurley, New York, thank you Hudson Valley Farm Hub for generously hosting our disgusting research. These are the combined results. This really tall bar graph on the right is where we sprayed nothing. So you're dealing with 26 maggots and pupa per leek if you do nothing. That's more protein than plant at that point. On the other end of the spectrum, we have our illegal application where we've pretty much, even just with OMRI listed products, eliminated the pest from the leeks. But you can't do that, don't do that. So let's draw our attention to treatments D and G. Okay, so these were 2 applications and we were able to get the mean density of ALM in those leeks down to around 4 in each of those. And treatment D was applications in weeks 3 and 4. Treatment G was applications in weeks 2 and 4. So it seems like we're honing in on kind of this critical control period where if you're going to apply 2 applications of insecticide, trying to hit that sweet spot in weeks 2 to 4 after confirming oviposition scars in the plot is your best bet. You start too early, like in B, where we did weeks 1 and 2, you lose efficacy. You wait too long, like in E, you lose efficacy, okay? So just to, make sure that we didn't have some weird aberration with OMRI listed products, we did a similar trial with Radiant. So again, kind of the synthetic version of the same active ingredient found in Entrust on Nabishan scallions this past fall, and saw pretty much a similar trend. You do nothing, holy cow, you got 13 maggots and pupa writhing around in that scallion. No one's gonna eat that. You spray illegally 6 times in a row, you completely eliminate the pest. But look, here again, weeks 3 and 4 and weeks 2 and 4, we get really good suppression of that pest with just 2 applications. That Radiant was co-applied with Dynamic, which is a penetrating adjuvant. So again, we're trying to get through the wax of that Allium leaf and get that product to kill some of those maggots inside the leaf tissue. Okay, I know I'm going really fast and I apologize. But hopefully we'll have some time for questions. All right, so that's it for insecticides for now. So we have also researched some cultural control methods, and I apologize in advance. There are 2 things I hate recommending to growers. One is reflective mulch, and the second is row cover, because having used both as a grower, I know that you're either gonna have to buy really nice sunglasses for all of your employees so they don't quit, and row cover is just always a mess. But here we go. Now I work for Extension, I get to recommend this stuff. So there's been some research that some of these fly pests are sensitive to UV radiation from reflective mulch, so we gave it a shot. And sure enough, these are 2 trials that were conducted in the fall of 2018, and in both on leeks and on scallions, we see about a 35% reduction in the density of Allium Leafminer maggots and pupa per plant. I do want to draw your attention, though, to the fact that you're still dealing with 9.32 maggots plus pupa per plant, which I don't know what your market is. I wouldn't want to try to sell that. Definitely better than almost 15, but still not good enough. Now, what if we look at that spring flight where we don't see as much pressure? Well, at least from this data set in 2019, comparing reflective mulch to black mulch, we started out with 0.8, which is okay, but we were able to get all the way down to 0.332 maggots and pupa per scallion by using reflective mulch, which seems to suggest that it's possible that maybe in the spring flight, if you're dealing with ALM pressure and want to be extra cautious, just planting on reflective mulch alone might be a viable strategy, but only in the spring, not in the fall. So since we still want to improve what we get over reflective plastic mulch, the next logical question was, what do we combine reflective plastic mulch with a couple of well-timed applications of Entrust plus Impede, like we saw in that timing trial data, where we were able to get pretty good suppression with just 2 applications of insecticide. And here we go, bar graph number 7,333. What we're looking at here is these 2 bars on the far left is where we sprayed no insecticide. Still see that trend towards a reduction in density with reflective plastic mulch, but you're still sitting with 30.8 maggots and pupa per leak. If that's all you do, which is, yeah, no comment. So first we thought, well, maybe between the reflective mulch and 1 application of Entrust and Impede, that would be good enough. And it does help. We get all the way down to 14.1 with just 1 application in week 3 of Entrust plus Impede, but still not very good. So you can see here, best treatments are we combined the reflective mulch and the 2 applications in weeks 2 and 4 of Entrust and Impede to get all the way down to 2.38 maggots per leak, which doesn't sound like a victory when you're still dealing with maggots in your leak, but we were feeling pretty confident that this might be a reasonable management strategy for organic growers to deal with this pest in leaks. We were thinking that. And then came 2020. So thank you to Northeast SARE for supporting these 2 trials that we'll talk about very quickly, where we basically evaluated a combination of different tactics. Everything in these 2 trials was planted on reflective plastic mulch. We just decided reflective plastic helps a little bit. Let's just go all in on reflective mulch. And then we wanted to look at different combinations of Protect Net, the BioThrips Protect Net exclusion netting, and the DeWitt 55 weight floating row cover, using it with hoops, without hoops. I have a couple growers who really insist that they only will use row cover without hoops, which I think is absolutely nutso. But you know, they were very influential in the trial design apparently, because we did it. And then we also had treatments that looked at reflective mulch by itself, as well as reflective mulch with those 2 applications of Entrust plus Impede. Now, probably everyone on the panelists has had the experience where you design a trial and it's a no-brainer. Of course, it's going to work. We got no pressure. We got no Allium Leafminer activity in spring of 2020. Now, we don't know exactly why. I think possibly since we use the reflective mulch and we have less pressure to begin with, that maybe that was enough to just keep them out of this plot altogether. Maybe that's wishful thinking. But it just kind of reiterates the fact that the spring flight is not the one that we really need to worry about. I do want to just really quickly, because Trevor Hardy, I think, was on the call, and he promised me 10% cut of all the weed mat that was sold. So look at those beautiful weed-free furrows. Holy mackerel. You too can be just like us. Anyway, so in the fall,
sorry, do you think that the weed mat influenced the numbers of the insect, or no, it's just good for weed control?
Yeah, it's a good question. I don't think so. Typically, you know, this was a field that didn't have an allium in it in the previous year, so all the adults would need to be flying in from elsewhere. And as you'll see in just a second, we got plenty of pressure in the fall using weed mat in that leek planting. But it's a good question. We don't have an answer to that. Okay, so we did the exact same thing, exact same treatments with leeks in the fall, and here we go, bar graph again. So the far right, where we have 33.8 maggots and pupa per leek, is where we just used reflective mulch. This next worst treatment, we often get calls from growers who say, hey, I saw that you announced the beginning of the fall flight of Allium Leafminer, and we were going to cover and we didn't cover, and 2 weeks has passed, and should I go out and cover my crop now? And we didn't have a good answer for that. We do now, and the answer is no. You should not go out and cover your crop after 2 weeks. You'd be much better served by going ahead and making those 2 well-timed applications of Entrust and Impede at that point in weeks 2 and 4. I do want to point out, though, that that treatment with Entrust and Impede only got us down to 7.7 maggots and pupa per leek this year, which was a little disappointing and begs the question, where do we go from here? And we're trying to figure that out. Now, real quick, if you want to pop something in the chat, why do you think Protect Net with hoops installed for the duration of that fall flight, excluding all the adults theoretically from that plot, still resulted in 20.2 maggots and pupa per leek. How on earth is that possible? Those leeks were tucked in, completely protected. That fly can't get to them. Any thoughts?
Someone said they pupate in the soil.
That's definitely, if we would have planted into ground that had alliums in it in the spring, that would have definitely been a problem. How about extension specialists don't know how to use row cover very well?
Oh, busted.
Just look at that picture real quick. We thought we were getting real inventive here with this double hoop system to give us a little bit more vertical clearance for that nice leek crop to develop. And what it ended up doing, at least this was the slightly under 7 foot wide protect net. It ended up making just a beast, a nightmare to try to anchor on the side. So we were putting ground staples through this stuff. We were throwing sandbags on it and just kept sneaking up over the wires. So we were basically just, like cracking the door open and inviting all the Leafminer adults to the party. So that was disappointing. But anyway, back to the bar graph, which is way more exciting. I do just want to point out, even though that failed, the fact that we were able to use that DeWitt 55 weight row cover without hoops, which is basically the same as the Agribon AG19, and get really, really good control, suggests to me that if you are one of the 7 growers I've ever seen use row cover really effectively, which means not allowing huge gaps on the sides and on a windy day trying to bring it down out of the tree, then it can be a strategy that works. But you're talking about 7 weeks of keeping those leeks covered, because even taking the row covers off early, 2 weeks before the end of the flight, resulted in 11.2 maggots and pupa per leek. So anyway, some promise there, but definitely, I think if we do this again, we're going to try the 10 foot wide protect net and see if we can get some better results. And maybe we'll buy some more sandbags from Trevor, right? I do just want to point out real quick that the marketable yield out of that plot where we used just the row cover without hoops was really high. But the question is can you sell that leek that is pictured here? Do you have a market for boomerang leeks? I showed these pictures and the leeks to a number of former leek growers in the Hudson Valley, and they were all like, look, we just stopped growing leeks because we can't grow a marketable leek with Allium Leafminer. We'll sell a curvy leek, that's fine. But basically the weight of the row cover just sitting on top of that crop canopy distorted probably 80 to 90% of the leeks in that plot where we didn't use hoops. And even in some of the ones where we did use hoops, leeks get really tall, and they were pushing up against the cover by the end. So everyone likes a nice summary slide with no pictures and a bunch of black text. So here you go. If you're using insecticides in your conventional grower, Exerol, Radiant, Scorpion are all good options, Polyminecta Pro as well. If you're organic and you want to use insecticides, Entrust plus Impede is really your only option currently, and try to target those applications, just 2 of them, sometime in weeks 2 through 4 of the flight. Reflective plastic mulch can help and might be enough in the spring, but it's probably not a good enough strategy alone, especially in the fall. And combining those 2 applications of Entrust and Impede with reflective mulch definitely helps. And there is some promise with row covers if you can get it on and keep it on for the entirety of the flight. Thanks to a bunch of people who helped with the research and the funders, and I will stop talking at 5 o'clock on the dot.
Woo! Excellent. Thank you so much, Ethan. That was awesome. Learned a lot about this new pest that is probably in our neighborhood.
I'll just jump in here and say, Ethan, there was a question for you. Somebody asked if there are any natural predators.
That's a great question. And some of our colleagues at Penn State and Shelby Fleischer's lab are actually looking at that question. Some of the maggots that have been extracted from trial plots do seem to have been parasitized by something. And so that identification process is ongoing. It doesn't seem to have helped with any sort of meaningful suppression yet. Andy, you're muted, so we didn't hear what you just said. Sorry.
Sorry. Okay, I'm with you now. Somebody in Litchfield County, Connecticut is saying you should add that county to your map.
Yeah, I think this pest is probably pretty underreported in our area, and maybe just encourage folks to, if they do have samples, even just send a picture to your extension agent, whether it's Suresh in Connecticut or Andy in Rhode Island or me in Massachusetts. Just send us a photo so we can begin to get a better sense of where it is.
I think so. We could open this up now. If people have questions in general, let's see. I'm not sure if Andre is still with us. Anne appears to be with us. So questions for Ethan or Anne?
It looks like Andre just is jumping back on now. And if you have a question, you can either put it into the chat box, or if you raise your hand, we can allow you to unmute yourself if you want to ask a question with your voice.
Or you can do an interpretive dance.
There's one question. Would you use regular row cover instead of ProtectNet given the vast difference in cost? Ethan, that sounds like it's for you.
Yeah, we got data as well on disease severity and marketable yield, thinking that, you know, anecdotally, we've definitely heard from some growers that they're concerned about putting alliums under cover for that long and seeing purple blotch maybe blow out. We didn't see any difference in disease severity or even marketable yield between ProtectNet and the row cover, except for what we saw in terms of actual allium Leafminer damage. So it definitely seems like if you'd rather use UMaine, go for it. Obviously, and I'd let growers chime in on this, even though it's more expensive up front, everyone I work with saves that ProtectNet and uses it for at least 3 or 4 years, depending upon how cheap they are.
Looks like there's more questions in. Somebody's asking about, are chives susceptible? I had a large neggy type that was infected, but the chives in the same bed were not. This was in the fall.
Yeah, we've definitely seen mining damage in chives. And since if it's managed as a perennial, like most chives are, the concern is that, you know, that pest is going to be pupating and then reemerging right in that same spot with a viable host right there. But you're not going to see, obviously, like the associated bacterial soft rot that comes with it. So depending upon how pristine of a chive it needs to be in terms of having some of that like mining scarring on the leaf tissue, you might be okay. But yes, we have definitely seen it in chives.
And it looks like somebody asked about overwintering of the Leafminer in Vermont, and Anne Hazelrigg has answered that. We have not found the Allium Leafminer in Vermont yet, but once we find it, I assume it will overwinter.
While we keep doing questions and answers, I'm gonna run the quiz for folks who want pesticide credits. But everyone else is definitely welcome to keep on posting questions, and maybe Andy, if you want to facilitate that, that would be great. And
yeah, someone had asked about, has Andre done any trials with row covers over potatoes? And Andre did say row covers were very difficult to keep on, and we eventually gave up.
Yeah, I mean, I did some, I didn't specifically test them, but I needed to exclude beetles for a different experiment. So we tried using covers on the hoops, and it basically didn't work out because they kept being ripped up or dislodged or whatnot. I think it's possible to use them early in the season if you're concerned about large overwintering population. Maybe you can keep it for a month on small plants. Whether it's cost effective or not, quite honestly, I do not know, but it could be an option. Success with planting potatoes after June 4th. I mean, it's possible. It depends on variety and depends on how lucky you are with the weather. So yeah, we did it. I mean, I guess it may also be possible for growing seed where you don't need to have size as much as you do with other markets. But, you know, manipulating times of planting is all, you know, you always have to consider agronomic considerations and market considerations versus pest control. So the BT question, yeah, there are BT control products. Right now there is a Trident. When they're trying to improve formulation, we're doing work with that. I will be having a phone call in a week about possibly another one. I don't know details yet. So hopefully, and I would highly recommend Trident if you can get it, to somehow rotate it with Entrust. So for organic growers, I think it's the only viable alternative to chemical alternative. Well, I guess insecticidal alternative to Entrust.
According to Greg Rogers at Certus, they are expecting to have Trident available in 2022. Parasitizing wasps for potato beetles?
There is a Dovon Potleri in 1980s. Everybody was very excited when it was found in South America. It does not provide economically meaningful levels of control. So no. There are two species of parasitic flies which are naturally present in the area. Sometimes they can hit beetles pretty well, but you cannot really rely on them. There are also predatory bugs, and there are ground beetles which would feed on eggs and larvae. And there is a pink lady beetle, Calamigilla maculata, which is quite good in eating eggs. So all of them together can push populations down, but you know, with one female Colorado potato beetle laying like 600 to 1200 eggs, they basically outbreed whatever natural control enemies are there.
Andre, I worked with Ellie Groden in 1993 on Coleomagilla maculata.
How did it go?
They liked the eggs, but they didn't put much of a dent in populations.
Yeah, that's my experience as well. So again, if you have a well-managed system that has good natural enemy population, they will have their impact, and maybe sometimes they even take care of that, but of the problem, but you cannot rely on this, and this is a problem. One way to enhance natural enemy populations while interfering with the beetles is to put mulch in. So again, on a large scale, it's probably not feasible. On a smaller scale, something like straw mulch or living in killed mulch, it helps.
Someone has a comment which actually is along the lines of my own interest. It says, Lower New England, do we need to worry about the leek moth moving south to us this coming season? And that would, I don't know, or Ethan.
Yeah, we'll do a switch. We'll do a change. I assume leek moth is going to keep spreading, but Ethan, you guys don't have leek moth where you are?
No, not in the southern part of the region that we serve. And so it does seem, I mean, it's interesting. We definitely suspected it would have made its way down to where I'm based by now, and it hasn't.
Yeah.
And so I'm not sure, you know, what's governing its dispersion or not. Swede midge, yes, definitely be scared of Swede midge. Should we stay here till 7 talking about Swede midge?
Actually, I have a question for Ethan about, because we're not seeing, in Rhode Island, we're not seeing Leafminer. Not that I know of. No one's reported it to me. I've done a little bit of scouting, haven't seen anything, except I saw something that might have resembled it back in September on some wild garlic growing right here on the farm where I live. But I wasn't sure. I never sent it in to diagnose it. But is it noticeable on wild alliums?
Yeah, I guess there was a period when we were really intensively scouting, and every time I went on a hike with my son, he became an expert at spotting the oviposition scars on onion grass, just out in the woods. So the oviposition scars, if they're fresh, are noticeable. So if you saw it in September and they were freshies, then yeah, sure, maybe. But it'd be very surprising to me if it had made its way that far east. So follow up on that and let me know what you find out.
Technically, I'm just over the border in Connecticut, so. But,
okay, yeah.
There was a comment from Trevor a while ago saying if you're an NEVBGA member and you need to renew your membership, this is your reminder to renew your NEVBGA membership, says Trevor.
There was a hand up. I don't know if William.
Yeah.
Oh, there you go.
Can you hear me?
Yep.
Years ago, we used cryolite for potatoes before, I guess it was Timmick came in. It's quite effective. Now, no, it wasn't an insecticide really. It put a glass cover on the potatoes that when the bugs ingested them, cut their insides. Is any reason that wouldn't come back or could be used so we get away from some of this pesticide resistance?
Well, yeah, cryolite can be an option. The problem with cryolite, it's very hard on nozzles, for one thing, and it is a physical poison base. I mean, yeah, so it's like a version of the diatomaceous earth. It scratches them to death. So it's not particularly selective either. You will damage, other things that you may not want to damage. But yeah, it is an option. I think it's still labeled for beetle control. So if you have a problem with spinosad, you can use it. I don't remember actually from the top of my head if it's OMRI approved or not. Others.
I don't think so, because I think it's a rock that contains fluorine, fluoride rather.
Yeah, it's aluminum fluoride. Yeah, I mean, it does work, but I don't think it's the best available option for conventional growers.
Thank you.
All right, any last questions? Toss them into the chat box or we will wrap up.
Yeah, and our next meeting, let's see if I can quickly put this up here. Where was, oh, nope. Our next meeting is the 28th, and we'll be talking about winter spinach, some sort of online field day. So hopefully we can catch some of you again in 2 more weeks. And the full schedule is, you can go to our website, UMass ummaine.edu/vegetable, and all the other 3 workshops are posted there. You can register, and we'll hopefully see some of you in the future virtually. Thanks to all the
Bye.
presenters. This is great.
Okay,